Mike Cathro, on behalf of the Kamloops Exploration Group, I want to welcome you to the seventh and final installment of the 2021 Kamloops Exploration Group Technical Talk Lunch Series. Today's topic is Uncovering the Quesnel Terrane, Geoscience BC's Central Interior Copper Gold Projects. Before we begin, I want to acknowledge that we're hosting today's talk from the unceded traditional lands of the Secwepemc Nation. We hope you found this series to be informative and instructive. KEG intends to continue this lunchtime webinar series in the fall. In the interim, we have two prospectors showcase sessions planned for noon on May 11th and May 25th. More information is available under the lecture series page on the KEG website. As always, we'd like to thank ALS Geochemistry for sponsoring the 2021 Technical Talk Lunch Series. ALS has been a longtime supporter of the KEG organization, and we appreciate their support. Just a reminder on how this webinar will work. Your mic is muted and your video is turned off. Throughout the talk, if you have questions, we will ask that you type it into the Q&A tab, and we'll try to get to them at the end of the talk. All of the talks are available for later viewing on the KEG website on the Technical Talk Lunch Series page where it says On Demand. The videos will be posted about 1 week after each lecture and will stay up until the end of May. This talk is about 30 to 35 minutes and will be followed by 10 minutes of questions, so we should wrap up about 12:40 or so. Our speakers today are Dianne Mitchinson and Dave Sacco, representing Geoscience BC. They're going to be speaking about multi-year research projects on exploring undercover in central BC, work they've been doing for several years as part of the Central Interior Copper Gold Research Project of Geoscience BC. Dianne Mitchinson is a research associate at the Mineral Deposits Research Unit at UBC. She's a geologist that specializes in integrating and interpreting geological and geophysical information to help identify buried porphyry and other deposits. Dave Sacco is a surficial geology and exploration specialist at Palmer Consultants. He develops exploration strategies for surficial environments. Their biographies and a brief abstract of this talk are posted on the KEG website. So welcome, Dianne and Dave. And Dave, I guess it's over to you to start.
Thanks for the introduction, Mike. I will start sharing my screen and we'll get right into the presentations here. So I'm going to start with a few slides that were provided by Geoscience BC and just discuss a little bit of the overview of the CICGR project. So CICGR stands for Central Interior Copper Gold Research, and it's a series of projects that are focused on an area of the Quesnel Terrane where there is a noticeable gap in the mineral occurrences, or known mineral occurrences, I should say. And so this area occurs within the Fraser Basin, which is characterized by very thick sediments, thick drift package, which is likely related to why we have so few occurrences or known occurrences there. So the projects are ultimately looking at how to, focused on how to explore under thick drift. And there are two projects currently going on, the surficial exploration project, which I'm going to talk about in a moment here, and the identification of new porphyry potential undercover, which Dianne's going to talk about when I finish up. So what is CICGR? How is it answering the question of exploring under thick drift? So it's a series of projects that are creating public geoscience data. So this is all the results of this will go public, and explorers can use this to help their exploration projects. And it's in coordination with the government. So the Geologic Survey of Canada and the BC Geologic Survey are involved in sort of the planning and execution of these projects and consulting on them. And there's also a lot of other planning engagement that go into this. Geoscience BC has a technical advisory committee who chooses projects that they think will be most beneficial for the public. And also communities and mineral sectors are going to be involved and have their say in what they think is going to be most useful and put in their 2 cents. And of course, consultation with the Indigenous groups that are in the areas we're working and what their interests are. So Geoscience BC has committed $2.9 million to this over 50,000 square kilometer area of interest, ultimately looking to improve our understanding of geology focus the mineral exploration into the more prospective areas and really spur some investment in exploration in these areas. We know that there's potential there, but it's a difficult area to explore. And then the last point here is to help inform natural resource decisions. So a lot of the information that's going to come out of this is applicable beyond just exploration. So I'll move on to the surficial exploration project. So as Mike mentioned, I'm Dave Sacco, and I've got Wayne Jackman on here from Noble Exploration. He's collaborating, we're collaborating together on this project. So the rationale for this project is there is thick drift in this area, and it obscures most of the bedrock. So we need to find a method of exploration that works under cover, that works where the cover is substantially thick. There's just a photo here. You can see a few people for scale. This is about 60, I guess this section was about 60 meters tall. If you got 60 meters of sediment averaging over the bedrock, it's going to be difficult to do exploration. Now, this overburden, as it's commonly called, is actually a dynamic tool for exploration. So if we can understand this material in the context of the bedrock, in terms of the composition and also the displacement from the bedrock source, we can use this as a tool to vector back to where mineralization might occur. So the overall purpose of the surficial exploration project is to provide high quality surficial data and the context required to evaluate that data, figure out where those bedrock sources are, ultimately providing reliable exploration targets. So we've already discussed a little bit where this project is located in central BC. The figure is a little bit small here, but you can see the blue outline is the CICGR project. And just for a little bit of context, there's some previous projects that I'll talk about. One is the TREC project in purple down here. Another is the Quest project, which is, you can't really see it, but it is basically all these yellow dots. Sorry, I'm on the wrong monitor. All these yellow dots over here. I guess those are the two that we'll talk about. And the surficial study areas for this current CICGR project are highlighted in red. And these study areas were chosen largely because we have this overarching goal of, as an exploration community, we'd like to provide this baseline of exploration data, of data that is continuous across a majority of the province, that, anybody who's interested in exploration can use this as a starting point. So we're building on these previous surveys. That's that TREC survey again, which you can see the green symbols here, the Quest survey. And the particular areas we chosen were roughly based on 1 to 50 NTS map sheets, and there's roughly 12 of them. You can see the shapes a little different down here. But overall, these are roughly 12 NTS 1 to 50,000 map sheets, a little bit under 10,000 square kilometers. And they're areas that are prospective. So we've looked at the geophysics and figure, okay, well, these are areas that are of interest, thick drift, so difficult to explore otherwise. And suitable for regional till sampling, which is the method that we'd like to use moving through here. So the approach is ultimately it's drift prospecting. We're looking at the drift, we're relating that back to the source. It builds on years of studies by, in Canada and British Columbia by this different surveys, and also internationally in other glaciated terrains, drift prospecting has been used. The specific model that we're using is really based on the TREC model that we accomplished. I guess we finished this project up about 3 years ago now. And it was a really effective model that ultimately culminated in nearly 100 anomalies, surface sediment anomalies, and over 50 of them are not associated with known sources. There's no min-file occurrences or anything like that associated with them. And the fact that half of them were associated means that the method works. We're identifying signals from this known mineralization, and also that the area is still very prospective and probably underexplored. There's a lot of opportunity to work in this area. So we've taken a data-driven approach, is kind of how I've termed it here. So really, we want to understand what we're working with and making sure we're making decisions based on the data that we have and the best decisions for the project. So we start with surficial geology mapping. This helps us understand what materials are around, how they relate to the bedrock, transport, things like that. We also look at the existing data. So lots of previous surveys have been done in the area, typically by government, specifically in the CICGR area. These are mostly government surveys or previous Geoscience BC surveys. So looking at what data is there and making sure we're using that to its full potential. And then also collecting new geochemical and mineralogical data where there are gaps. So starting with the surficial geology mapping, these are 1 to 50,000 scale interpretations. They are using the same protocols that the BCGS would be using to produce their map. So these are compatible products. And this is intentional. Again, we want to be building this larger data set. So we want this to integrate with the other public geoscience information. So we're using the same protocols, essentially mapping this the same way, trying to produce maps that are very similar to what you would see from the survey. And it provides us an understanding and inventory of the materials. So what's there, what are the best methods we can use and for exploration, and where do these materials come from? And from this base surficial geology mapping, we drive a few products that help us with our exploration efforts. So the first one is till sampling suitability mapping. So this is essentially we're creating a stoplight sort of picture saying what areas are suitable for till sampling and what areas are going to be more challenging. And it allows us to do a few things. First of all, when we're executing the survey, it allows us to position our samples in such a way that we can get the optimal sample spacing. So if we know where we're going to have good material, we can choose where we're going to put our samples to get that optimal spacing again. It also indicates areas where we may have to work a little harder. So sort of the mid-range colors there, the lighter greens and the oranges, where there is still potential for till, but we're going to have to, spend a little more time possibly there, or look for the specific situation. If it's orange because there's a veneer of glacial accustomed material overlying the till, then we know that we need to look for an area where there's likely to be large road cuts where we have access underneath that overlying material. And then it also tells us where we shouldn't bother going. For example, on the right side of this map here, this large dark orange area, just all large outwash plains that we're not likely to find any till at surface there. So we're not going to go there. The second product that comes out of this is drift thickness mapping. This is relative drift thickness mapping. So it's really based on the surface expressions that are identified in the surficial mapping. So areas where we have bedrock identified, so the pink areas on the surficial map here, or till veneer, which are the lighter greens, they end up being these lighter colors indicating that bedrock is relatively close to surface. If you've got a geophysical anomaly there or something, you can go to that area and actually crack some bedrock off the ground and get it assayed. Sort of the intermediate zones are areas where you might be able to get an excavator in and access bedrock. And then the deeper zones, again, we're looking at the east side of the map here, where the material is thickest. You probably aren't going to access bedrock unless you have a drill or something. And this also informs our till sampling programs and whether or not in these deeper areas there is valuable information buried within that deep stratigraphy, and it identifies whether or not it's worth going in with using a drill supported till sampling program to understand stratigraphy and to collect geochemical data that may be valuable for exploration. So talking about geochemical data, so we'll move into the data compilation and reanalysis. The map on the right here, I mentioned the TREC project a few times now. So the green symbols represent the TREC project. And this is a result of the historical data plus the new sampling. It's kind of the goal that we're going for expanding throughout BC to have this sort of till sample coverage. So the existing data largely coming from government surveys, or Geoscience BC surveys, both of which have archived sample material. And what we want to do is reanalyze that data where possible to bring it up to the most modern standards that we can so that it's directly comparable with the new material or the new analysis that we're going to produce. So the goal for both of these programs was to have a clay and a silt plus clay size fraction, or analytical results from both of those size fraction from a 53 element ICP-MS package, as well as INAA, and the major, minor, and trace elements, or whole rock, with the ICP-AES/MS for the trace elements on that side. It's a very robust data set. The analyses provide sort of different levels of information. Some people like one, some people like the other. Ultimately, altogether, it's incredibly valuable and offers a lot of information for explorers to use and hone in on some targets. So as far as the reanalysis goes, we were able to capture or retrieve, 288 reference standards from the GSC. So these are processed splits of the silt plus clay and have those reanalyzed. And then from the Quest project, we were able to recover 672 character splits. So this is actual split of the original material. And with the reanalysis, we'll basically run whatever is necessary to bring it up to the level I've described above. So for example, the character splits, they had the ultratrace run on the clay, but not silt plus clay. So that was the analysis we ran for that, culminating in all of the different analysis for all of those archive samples. And then the next thing is new till sampling. So once we've looked into the archives, looked into historic data, found out what we can bring to the modern standards, and identified basically where the gaps are, we've gone out, we've already started this, go out and collect till samples that are going to fill in those gaps. So the target is subglacial till. Could be a lot of discussion why it's specifically subglacial till, but essentially this is material that's been eroded at the base of the ice, it's been transported at the base of the ice, it's been deposited at the base of the ice, and it hasn't moved since then. 10,000 years, it's been sitting there doing nothing. We want to get into a relatively deep profile, or we want to sample from below any soil formation or cryoturbation, or bioturbation, wrong environment, any bioturbation that may affect the chemistry. So we want to get into that original in situ parent material down below. So our target spacing is roughly 2 kilometer target spacing. And the idea here is that you're going to capture 1 or 2 samples that are anomalous, and that's going to be enough to highlight an area that you would go on with a higher resolution survey. So where there are no existing samples, every 2 kilometers in a grid, roughly staggered perpendicular to ice flow. And then where we've got existing, like the recon samples that the GSC did, were basically just fill in the little gaps in between. They were 4 to 5 kilometer spacing. Some cases upwards of that. We would just put in whatever's necessary to infill that to the density that we want. So at every sample site, we're collecting material for geochemistry. We already talked about those different analytical packages. And then at about half of that density, we're collecting material for mineralogy. So it's the bulk sample, a 10 kilogram sample that we're sending to get gold grain counts, porphyry indicator minerals, and that sort of thing. In addition to that, we're collecting 50 pebbles from every sample site, and these are for lithological provenance studies. We can understand a little bit more about transport distances. We can understand basically composition, bedrock composition of ice using some of these pebbles, and looking at the proportions of the different lithologies to sort out a little bit more, to provide a little bit more understanding of the underlying bedrock. So where are we now? We've completed the surficial geology maps, and they're in review for the top 6 map sheets. So they will be, they should be released in the next month or 2. And so that's the surficial geology map, till sample suitability, and the drift thickness mapping. All of these will help anybody who's going to go back in, follow up on the anomalies that are produced. They're going to help design and execute those surveys. And the reanalysis is ongoing. We've got most of that data back. It's just in preparation to be released. There are still a few hundred samples, I believe, at the GSC storage facility, but due to COVID, I don't think we're going to actually be able to recover those, which is a little unfortunate, but we were able to get nearly 300 of those samples out of there. So that is also currently in review, or being prepared for release, sorry. And then last summer, we completed our first field season of sampling, and all these purple dots represent the samples that we were able to collect in that first season. And we'll be finishing up that survey this year. in the summer of this year, so filling in the gaps down here in the south. And while we do that, we're also collecting ground observations that we can use to refine and finalize the maps down here. And then those maps and that data will all be released as well. The results from the sampling are currently trickling in right now. So we won't be releasing that quite yet, as we're still waiting for some of those analytical results to come back. So what are the next steps for CICGR? So for the surficial exploration project, as I mentioned, we're going to do our final field season this year and finalize the mapping and finish off all of the maps and get basically that giant data package out to the public. And then the next stage of the project, or the next big project coming out of this, is an overburden drilling program. So this is going in with a drill to target areas where the drift is specifically thick, and really areas where standard surficial tactics won't work. So if you don't have till at surface, then you can't do till sampling. If you have thick glacial custom packages at surface, like we do in Prince George, you're going to need to get below that, and that's sort of the idea of this program, that we can understand that stratigraphy a bit better. What are these thick packages made out of? What's the composition, the genesis of that material? Is some of that material going to provide us information to help exploration? And there's also a little bit of a push to convert these to legacy wells for future water monitoring and research. And this project is currently in the planning stages. So permitting, obviously, it's a bunch of drill holes, so those need to be permitted, and consultation with the groups in there. And COVID restrictions are, as usual, causing some hiccups for field programs. But that is in the planning process, and will hopefully coming down the pipe soon. So just the last slide here, quick enlarged business card. Obviously, feel free to reach out if you have any questions about the CICGR project or other surficial exploration questions. And from now, I'll turn it back over to Dianne. Thank you.
Thanks, Dave, for your presentation. I'll start mine up and share my screen. Okay. Okay, first of all, I would just like to thank the KEG for inviting myself and Dave to come and speak today about our Geoscience BC projects. We had hoped, I think, both of us to attend the actual KEG conference this year, but unfortunately that couldn't happen. And this is, I think, just a great opportunity to do this lecture series as an alternative and to reach quite a lot of people this way as well. So that's quite nice. Thank you very much. So I'm talking about the MDRU Geoscience BC CICGR project, identification of new porphyry potential undercover in BC, where we are digging deeper into central Quesnel terrane geophysical data. So what is the motivation for this project? Well, first of all, I'll just point out the project area. In the lower left here is a map of BC with the project area in white. And then on the right, the project area is on this terrain map of BC in black. And basically, there are a lot of people interested in what is hiding underneath this quaternary cover in the Quesnel terrane. And if you can note here, the min-file occurrences where I have symbolized the alkalic porphyry style deposits in diamonds in yellow, and the alkalic style porphyry deposits in the circles in white. And of course, we have the map here, and there are numerous alkalic and calc-alkalic style porphyry occurrences in the north, and then near Mount Milligan and north of that. And then in the south, same thing, a whole bunch of occurrences south of and around Mount Poly. And in between, it looks pretty sad. There's not very many occurrences. And so is there really nothing there? I'm doubtful of that. Many people are doubtful of that. We've got the right geology, we believe, that continues on between Mount Poly and Mount Milligan. So, and I think we also are getting better and smarter at exploring undercover. And I think that we're gonna start to find more things in that area of BC. So that's the motivation. And just sort of a bit of information about the data that's available in the Quesnel terrain. It's a geophysical data gold mine, really. There is so much data available, and there's been lots of work, studies, interpretations of geophysical data through that area that's been done, and so much to evaluate and consider and follow up on. And many of you probably have worked with this data. I'll show some examples of it. This is the Geoscience BC Quest area data, the VTEM EM survey, and the gravity survey supported by Geoscience BC. Following that data collection, Mira Geoscience did a suite of inversions using that data, the EM and the gravity data, building density and conductivity models. They also inverted magnetic data, so susceptibility models of the Quest region. And then they integrated the data and they developed some classification maps using those physical property models. And these almost end up being sort of like pseudo geology maps. This now is down in the southern Quesnel terrain from the Quest South gravity data set. Mike Thomas at the GSC did some interpretation of that data, also very interesting, pointing out where different intrusives are and where different sort of volcanic rock units sit. And so that's quite an interesting study as well in the southern Quesnel. Back in the Quest area again, Sanchez et al. Did some structural interpretation using magnetic and gravity data, and also some interpretation from the geophysics of the geology of the area. And then recently, Mancian et al., they did a mineral prospectivity model for that Quest area, and basically integrating a lot of this data that I just previously pointed out, geophysics and structural interpretations and that kind of information to come up with a sort of a porphyry prospectivity map. A lot of great studies going through here. And so for this particular project, we decided to, we're digging down again into this same geophysical data that's available, but we're going to focus on some specific types of targets. The goals for this project, the new porphyry potential undercover project, are to first identify a suite of targets, and we're going to do that using magnetics. Assess the thickness of the overburden through the area so that we can sort of understand the feasibility of these targets. How thick is the material on top of these things? And we are doing that actually in a big way using the VTEM data that was collected by during the Quest surveys. Then we want to go back to the targets and further define their petrophysical and geophysical properties. So along with being magnetic, are they, what is their gravity signature and what is their resistivity conductivity signature? So we can kind of rule out rocks that we might not be interested in. And so this is a sort of a petrophysical plot showing rocks in the Quesnel terrain and their resistivities and densities. I'll talk a little bit about that in a few slides. And then finally, assess the prospectivity of the various targets based on their geophysical characteristics and their overburden and also other available data. So choosing targets. Well, we have Mount Poly sitting at the southern end of our project area and Mount Milligan sitting at the northern end. So these are both alkalic style porphyry deposits. And so we figured we would focus on this style of deposit for our project. And one reason the alkalic style of deposit are typically very gold rich, which is really interesting. A lot of people are interested in finding gold rich deposits. And they can also be enriched in PGEs. And also they tend to be magnetic. So they're kind of stand out a little bit usually. And so we looked to the south of the project area in the southern Quesnel to kind of get an assessment of what these things look like in the geophysical data. And so this is a map of this southern Quesnel terrain, and it's just outlined in with the green color there. And then this is on top of a magnetic map. And Logan and Skritza and others have identified four magmatic belts in the southern Quesnel terrain. and each of them are related to porphyry deposits. So 4 belts of different ages. 2 of those belts are alkalic in nature. And in particular, I've highlighted the 2 alkalic belts here in pink and purple. And the pink outlined sort of intrusions here are these late Triassic alkalic intrusions. And you can see that these are associated with the Mount Poly deposit, the Afton, New Afton deposit, also the Copper Mountain deposit. And these seem to be quite regularly magnetic. So magnetite bearing intrusions, oxidized alkalic intrusions. So this is what we decided we're going to go with. We're going to move up to the central Quesnel and the project area and start picking out some interesting magnetic targets. And with the assumption that we might pick out some things that might be alkalic intrusive host rocks, basically, for alkalic style porphyry deposits. So it's pretty simple here. We just did an interpretation of the mag data, looking for rounded magnetic bodies that cross-cut stratigraphy, similar to size of anomalies, to the size of anomalies of intrusions that are related to Mount Milligan, Mount Poly, Afton deposits. We wanted also to avoid things that are probably previously mapped as being unrelated, say ultramafic rocks, magnetic ultramafic rocks, and avoid stratigraphic magnetic anomalies. So for example, down here you can see some magnetic striping, and I believe this is more magnetite bearing volcanic stratigraphy. So things like that we avoided. So we came up with a set of about 50 targets. Okay, we have our targets, and so we took a step back then, and we decided we'd like to know, are these targets, whatever they might be, are they accessible for exploration? How accessible are they for exploration and mining, if they ever turn out to be something? So one thing that we noticed, and has been noticed previously, is that in the VTEM data, which was inverted by Mirror Geoscience, you can see thin layers of conductive material, and that looked to be like it was overburden or cover rock. And when we compared that to our observed data from drill holes and water wells and things like that, we were confident that this is actually what we were seeing. So that the overburden was coming out as thin conductive layers where it existed in the VTEM inversions. So we went line by line and interpreted our cover rocks from the VTEM inversions. So, so this does not just differentiate various types of cover in the way that Dave was discussing. And in places where the cover rocks are not conductive, we obviously don't see it in the inversion. So there are some assumptions made, but we're mainly assuming that the cover is conductive everywhere. We did the interpretation, and we're going to include this data now, our interpretation data, with the other available observed data to come up with a refined thickness model for the overburden in that area. So this is just a map showing all of the constraining data that's used to build a new overburden model. So some of this data has been used before to do some thickness modeling. So blues and reds are outcrop locations. So in those places, there would be no cover. And the green are water well data, and from that you can get bedrock information and also minimum thickness information, minimum thickness of cover. The black squares are exploration drill hole data, where we can also get information about the depth of bedrock. And you can see each of these lines here are interpretations done along VTEM inversion lines. So you can see how that is, and the black dots actually are interpretations along these lines where there was no cover indicated in the VTEM inversion. So this really fills in a lot of the area where we did not have constraining information before on the thickness. So taking all that data then, we interpolated it and we came up with our thickness, our revised thickness model for the central Quesnel terrane. So this is a bit of a working model. It's pretty much there. I think we're tinkering with it a little bit more and hoping perhaps to include some of the information from Dave and his team's work. But we think it's a pretty good model. And basically the main point of this right now, the slide, is to just show how variable exactly the cover seems to be in this area. So we've got cover thickness ranging from about 0 to 230 meters. Quite a lot of variability, maybe more than people expect. And in fact, over some of these targets, you can see that maybe we have very little to a very thin veneer of cover, which would be encouraging for anybody that wants to check out any of these targets or wants to drill in those areas. So yes, overall, perhaps there's less cover than one might expect, and it's encouraging for exploration, I think. The next steps of the project then, as I mentioned, the next thing that we're going to do is try to establish the full petrophysical character of these targets. So what we're working on right now is doing new inversions of the magnetic data and gravity data and VTEM data from that area. So what we're doing is modeling the magnetic data at each of these targets. So we have a magnetic target for each of these targets, and we're going to end up with some susceptible body that's causing that magnetic anomaly. And so this is an example here. I've pointed at one of the targets. We're just testing out some of these right now. And so this is one of the first results, magnetic inversions, local magnetic inversions that we've done. And so this is a susceptible body we think could represent a magnetite bearing intrusion that could be of interest. But the next thing we want to know is, does it have sort of other characteristics that might lead us to think that this is an intrusion that might host a porphyry deposit. So we're going to take, for each of these bodies, we're going to look at the density and we're going to look at the resistivity. And just to expand on that a little bit, then this goes back to that plot, and this is showing resistivity and density data for rocks in the Quesnel terrane. And this comes from the Canadian Rock Property Database, and also includes some samples from our own project, this project. And what you can see here is that volcanic rocks from the Quesnel terrane typically have quite high densities and have high resistivities. Volcanic sedimentary rocks, so the Quesnel terrane is, the bulk of it is volcanic rocks and volcanic sedimentary rocks, and it's a volcanic arc. So volcanic sedimentary rocks is the opposite, low resistivities, low densities overall. Intrusive rocks sit kind of in the middle here. They've got these moderate densities, moderate to high resistivities. So that's the kind of signature we want to see from these different magnetic bodies that we've targeted. And if they end up being quite dense bodies, then perhaps this is something else. This is not an sort of an intermediate style intrusion that might host a porphyry, but maybe this is a sort of a very high density volcanic rock or something where we can rule out that target. Finally, we want to prioritize all the geophysical targets that we've come up with, and we're going to do that using any other available data that we might have, some geochemistry. But one thing that I'm finding interesting right now is looking at sort of the distribution of these targets and anomalies, the sort of structural and geologic distribution of these things. And again, so looking back down to the southern Quesnel, this alkalic belt, this late Triassic alkalic belt, these intrusions that are cropping up seem to always kind of sit on the margins of these larger calc-alkaline intrusions. And the spatial correlation, that could be possibly related to some sort of shared structural that these intrusions are using to get to the surface. So it's probably a structural association or something like that that's causing these things to commonly sit together in space. So this map is a gravity map here from the Quest South. And basically I just traced out the gravity lows. So these calc-alkalic intrusions are typically big gravity lows. And then you can see these alkalic intrusions sitting adjacent to them. I didn't trace this one out, but this is also a low down here. And so then looking back up to the project area, we have a few of these gravity lows as well. And so I've been finding these pretty interesting, these magnetic targets here that are sitting on the edges of some of these bigger gravity lows in the central Quesnel region. And in fact, if you look closely, you can see that these targets, some of these are associated with sort of moderate density, or sorry, moderate gravity highs. So maybe these are sort of these moderate density, intermediate style intrusions that that might be prospective for porphyry deposits. So yeah, that's interesting to me right now, and we're going to further dig into that as we go along. So that's about where the project is right now. I just want to acknowledge Geoscience BC for supporting the project. Dominique Fournier and Craig Hart, essentially Dominique and Craig began this project with me, and basically brainstormed all the amazing ideas that are being played out as part of this project right now. Everybody at MDRU, I want to thank everybody's been working on this project, basically doing geochemistry and petrography on some of the rock samples, and it's just been actually a pretty big group effort. And so also UBC GIF working with Doug's group right now to do our new inversions that we're doing. Randy Enkin, who did the rock property measurements for the samples that we have, and Peter Kowalczyk, who reviewed our summary of activities report for Geoscience BC and just provides some great insight and ideas for us as we go. So thank you very much to everybody that's been listening, and back to you, Mike.
Very much, Dianne and Dave, for this very interesting talk on an important topic for exploration in BC. On behalf of the Kamloops Exploration Group, I want to thank all of the folks that have listened in today for participating. We've had about 75 people take part in today's lecture. I also want to thank ALS Geochemistry for their sponsorship and their continuing support of the Kamloops Exploration Group. One last reminder of our upcoming prospectors talks, which are planned for noon on May 11th and May 24th. There's more information on the KEG website. We'd love to hear your feedback and suggestions for talks for the fall, and you can send those to kamloopsexplorationgroup@gmail.com. Once again, thanks for all your support and for listening today. Bye for now.